right, let's go ahead and talk about, wanted to finish up, we didn't quite finish up that section that we were talking about last time in the book, but I also wanted to talk a little bit about number 5 and number 6 on Lab 10, just because I wasn't quite sure on that one if, you know, I'd rather kind of discuss it together, so that's why I didn't have you do those on there. But let's look at number 5, and I guess maybe, let me try something really quick here. So this one would be the amount of money lost when you spend $0 on advertising. Okay, and then the vertex of this, remember that's that turnaround point of our parabola that we're talking about, and remember we can find that because it's going to be smack dab in the middle of our two x-intercepts. So remember we said the way we could go about finding that is adding those together and dividing by 2, right? So if we do 24 plus 88, and take our answers that we got for our x-intercepts, and we want to find the average of those two numbers so we can figure out where it's at right in between them. And so then when I do that, I get 112 over 2, and then that will simplify to be 56. All right, so this is my, that's what my x is going to be in there, my x part of my vertex. And then I can use that number, that 56, and put it in place of my x's in the equation there to figure out what that would be. So if we put that in, let's see, this is such a long thing here. And my marker is a little bit harder to write with here. But a lot of this, I mean, you can just put this into your calculator too, you know, when you're doing this. But make sure, whoops, I want 56 in place of that x. All right, but I do want to see your work, like what you're thinking about. This is how you know, like on the test, you would be, you know, showing me, communicating with me what you understand there. And so when you do that, you know, simplify this, multiply that all together. I'll just go to the answer here, which is 1,024,000. Okay, and that is talking about money this time. Right? So, so on the answer part here, so remember that this x was in thousands, right? In thousands of dollars. So if you spend, $56, right, $1,000, right, $56,000, you get a maximum profit, or your profit would be the 1,024,000. Okay, so it's just kind of trying to help us make some sense of, you know, when we have some kind of a story problem, what the x-intercepts are meaning, what the y-intercept means, and what the vertex means. I just want to make sure that that is clear to you. And these are important parts of the parabola, so that's why when we were graphing them, that we always want to be able to figure those out. Okay. What questions can I answer there on that number 5? Is there something I could clarify for you there? Okay, and remember you didn't have to finish this Lab 10. I just wanted you to finish up to number 4. We're just doing number 5 and 6 together. And now that there's more of you on here, I mean, I was saying earlier that it kind of got messed up because I put you guys in groups, and I don't usually use groups on Canvas all that much because I usually have you guys just get together in groups in class. And so I didn't realize it would make you like submit one assignment per person. So just, pick whose assignment from your group you're going to submit, and we'll just go with that, and I'll give you points from that. So it can just be one person in your group. And then going forward, I'll know that is an issue. So sorry about that. Okay, and then let's look at number 6 also, just to make sure, if we have something like this, you'll know what to do here with something like this. So we're given this function, right? So we have this function, f of x equals 2x squared minus 63, and it wants us to find the x values. So you're really trying to solve it for x, but they want you to solve it for x when f of x equals 9. So remember, that means that's the same thing as saying y equals 9, right? Or where this f of x is, we're going to put 9 in place of that and then solve it. Right? So in order to do this, remember when we have something squared, and you had to do these on some of the ones up earlier, when you have something squared, you want to get one side equal to 0 so that you can factor it to try and solve it from there. And sometimes it's not going to be factorable, and we're going to talk about that today, what happens when you have something like this that you're trying to solve and it can't factor. There's a few other ways that we can look at those type of problems there. So let's look at this one though, first of all. So we're going to first subtract 9 over, right, to get 0 on one side there. And so then that's going to give us a negative 72 when we add the negative 63 and the negative 9 together. And then I can see that 2 is a greatest common factor. So I'm going to start there by always looking for that greatest common factor first and see if that will factor. Right? And so that gives us x squared minus 36 when I take negative 72, divide it by 2, I get this. And now when I look at this, I should see that those are a difference of squares. And so this can factor further, so I want to keep going. So I have 0 equals 2, and then difference of squares, remember we'd say what times what is x squared? That's x times x. What times what is negative 36? That adds to be 0. So that's going to be your negative 6 and your positive 6. Okay. And then it wants you to solve for x, so then we'll just set each of those parts equal to 0. But remember on this first part, right, this 2, there's no x to solve for there. So we don't need to, put that part equal to 0. Because if you did, you say, okay, 2 equals 0, well, there's nothing there to solve. So it's just kind of nonsense. And so nothing to do there. But we'll set the x minus 6 equal to 0 and the other factor of x plus 6 equal to 0. And so then when I add the 6 over here, I get x equals 6. When I subtract the x over, I get x equals negative 6. Right? So those are my 2 answers on this, and I expect to get 2 answers because remember my highest exponent in here was a 2. And so I talked a little bit last time about looking at that highest exponent. If that exponent is a 3, right, then you would expect to have 3 answers. If it's a 4, you expect to have 4 answers, and so on. Okay, but expecting to have 2 because that's our highest exponent. Right? Okay, I want everybody to try this one. Just do it on your own sheet of paper. It doesn't need to be on Lab 4, but I want you to try and, put, so h of x equals 1 this time. Right? So put 1 in place of h of x and then go ahead and solve that for x. Okay, so let me give you a couple of minutes to try that. And then just speak up if you have some questions, if you're not quite sure what you need to do, because you're not alone. Ask the questions that other people are afraid to ask. Okay, let's take a look at this together. I'm not sure how far everybody's getting on it, but so starting this out, right, you should subtract the 1 over to the right side, so we can get 0 on the left side. So we have one side equal to 0. And then remember that we need to multiply, right, those two outside terms. They call them A and C. You'll see sometimes in that in videos, just because usually our form is ax squared plus bx plus c. So they'll usually call this like the AC method because of that. Right, so you're multiplying those two together, you get 30, so you're thinking what multiplies to be 30 that adds to be 17. And then I just listed here, you know, some possibilities. I'm just kind of working organized to make sure I get all of them there, because sometimes it's easy to overlook them. So on this one, looks like the ones that will add up to be 17 is 2 and 15. Right, and so then you could rewrite this as a 4-term polynomial, where we're splitting that middle term up into 2 other terms. So I get 0 equals 6x squared plus 2x plus 15x. Right, that's my 17x is being broken down that way. But remember, it has to be broken down this way, right? Because that's the only thing that multiplies to be 30 that adds to be 17. Okay? And then plus 5 there. And then from here you could do either the box method or you could do the factor by grouping method. Some of you might choose to do the synthetic factoring. Others, you know, you have other ways that you may have learned in other classes that you like. So I just always want you to use what works best for you. I'm going to do just maybe the box method down here just to illustrate it again. Make sure anybody had any questions about this. All right, so you're putting each of those 4 different terms inside the boxes. And then you're seeing the common factors in each of the columns and each of the rows. Right? So in this first column here, right, I can see that there's a 3x that's common to both of those. So that's what I'm going to be factoring out of that, basically. Here, there's only a 1, and it's a positive 1, so I'll put a plus 1 there. And then when I'm looking at the rows now, right, I can see a 2x is common there. And then on the bottom row, I can see that there is a 5, right, and it's a positive 5. So that means that this is going to factor to be, so I've got 0 equals, in my first parenthesis, my 3x plus 1, and in my second parenthesis, my 2x plus 5. Right. Okay, now, are there any questions from there?
So does it matter how you arrange the terms in the box?
Not really. Like, even if I switch these around and stuff, I mean, you know, I mean, you kind of want to have it, it's going to be easiest if you have that x squared term up here and your 5 down here, but it doesn't matter where you put your 2x or your 15x, because you will end up with the same thing on that. Is that what you guys got when you factored it, or are there questions about how to get there? And if we FOILed it back through, would we end up with what we started with? Right? Because you definitely want to, if you're unsure on your factoring, you can always FOIL it back together and see if you can get back up to what we started with right here where I put that star. Okay. And then I can set each of those parts equal to 0 now. So I've got the 3x plus 1 equals 0, and then the 2x plus 5 equals 0. And then I can subtract that 1 over and divide by 3. So x equals negative 1/3. And then I'll subtract my 5 over, and then I'll divide by 2. So x equals negative 5/2. Okay, so that's what I should come up with for my 2 answers there. Raise your hand if you were able to get that. I'm just trying to see where everybody's at. And those that didn't get it, do you have questions about how to get that, or maybe it was just because you didn't finish it? Okay, well, I guess silence means no questions. Remember, ask those questions. If you have a question,
How do you raise your hand?
On the thing, you just, so right next to your name, there should be a little hand icon, and if you click on it once, it raises it, and if you click on it again, it lowers it. So do you see the participant box with your name in it?
I was curious because I couldn't find the hand.
Yeah, so sometimes, like when I'm sharing my screen and stuff, sometimes you have to go, so if you scroll, like hold your mouse over the top of the screen, you know, like this, then it's going to bring a drop down, and on there you'll see there's a chat box that you need to click on, and then a participant box. Because as I understand it, on your end, those things go away when I share my screen with you, but you can find them in that little drop down box at the top.
You know what page we're on?
This is the lab. I just did number 5 and 6 lab together, and you don't have to do these on, you know, you don't have to do this on your 10 lab. I just wanted to talk about these 2 together. You only had to do numbers 1 through 4 on the lab. Okay? And then we just talked about 5 and 6 together. So, so I just said, just put this somewhere on, you know, in your notes or something like that, so you have these to refer to if you don't have the lab printed out.
Okay, cool. Thank you.
Okay, you're welcome. All right, so let's go back to the book now. So we'll go into the book, and this is kind of where we left off on last time. I think in your book it's around page 125. Let me try and find that and get there. And so before we actually talk about a few of these problems here, there was one thing yesterday that I wanted to say to you. I got a little bit flustered because of all of the craziness with the technology and stuff. So I forgot to tell you one thing that I wanted to make sure that you knew, and that's the definition of the square root. And some of you, are familiar with the square root, but let's talk a little bit about this for a second. Right, so remember that square root is just this symbol, right? And if it doesn't have the number there in the little crook of the arm, if you want to call it that, then that's a 2 there, so that's a square root. If there's a 3 there, it's a cubed root, and so on. Right? But when I'm looking at something like this, this says, so the square root of x, right, is the non-negative number whose square is x. Right? And we talked about that a little bit when we said something like, the square root of 64 or something like that. And I said, okay, what number squared gives us 64? Right? And so I just want to make sure that you see, so this non-negative part of it is actually a really important part. When we're seeing this, it's called the principal square root. And so our answers are going to be non-negative. Some people refer to them as positive, but 0 is also, it is part of our principal square root. So 0 and positives, right? That's what I mean by the non-negative. It's a non-negative number there. Okay, but so let's look at this first one, right? So these are just some students' thoughts about inverting that function of x squared. So we talked about, yesterday, the inverse a little bit, right? And so some of these students don't have it quite right, and so we want to fix some of their misconceptions here. All right, so Jean thinks that g of x equals the square root of x is the inverse of f of x equals x squared. So she's saying that these two are inverses of each other. Somebody tell me what you would think about on that, or can you explain to us if you think she is correct, almost correct, wrong? Yeah, go ahead and just speak if you have. Just unmute yourself and tell us what you're thinking. Come on, guys, it's in your notes, just a few pages back.
I would say it's correct because a root is the opposite of a square. So
okay.
The square root undoes the root, but
Okay, so you think that she is correct in that? Okay. Anybody else have an idea? Do you think anything different on that?
I was thinking it was correct too.
Okay. So look on page 122. So on this, she's almost correct. Okay, there's something here that's missing. Remember we said, right, this, right, by itself is not invertible because it doesn't pass the horizontal line test, right? But we said if we just looked at half of the parabola, like this part of it, right, then that part would be invertible, right? So you're right in thinking, I mean, these are inverses of each other, but we just can't have the whole thing. So we only want the domain of our f of x to just be like 0 to infinity rather than negative infinity to infinity, which is what, that first green graph that I drew there of that parabola. The domain, as you look at it from left to right, would be negative infinity to infinity. And with the whole thing, right, it's not invertible. But if we just look at part of it, it is. So let's just say, something like this. So she is mostly correct, but needs to state the domain that we are looking at of f of x equals x squared is from 0 to infinity. Right? Because do you see that the pink part of this graph, that passes the vertical line test. But if we have both halves of the parabola, then it's not. So that's kind of the cool thing with, graphs. Sometimes we, it extends out in both directions, but for some, sometimes they're thinking, okay, for our purposes, we're just going to think of just, the, part of the graph, not the whole thing. Okay. Okay, what about part B? So Morgan thinks that the square root of 4 is plus or minus 2. And can anybody tell me why you think that Morgan might think that? What do you guys...
I think it's because she's saying negative 2 times negative 2 would be 4.
Yeah, so when we're looking at, so the definition, right, of this, so when we're taking the square root of it like this, we are just finding that non-negative answer, right? So the answer is just 2 on this. But what, I think it was Haley that was saying, if you take 2 and square it, whoops, didn't mean to write it like that. Right, if I take 2 and square it, I get 4, and if I take negative 2 and square it, I get 4. But that doesn't, so I want to make sure when you see this symbol right here, right, and you're just finding the square root of a number, then our answer is just going to be that positive number, because we're just looking at that, what we call the principal square root. All right, which means we are going to only end up with either 0 or positives for answers. We'll get to what they might be thinking here. This is when we can come up with 2 different answers like this when we're solving some quadratics, and so we're going to get to that next, but that's different than what we're doing here. All right, we're not solving for x here at all. So we're not taking, the square root of, some variable. We're just taking the square root of a number. Okay, so it should just be a positive 2 for our answer on that. Okay. In part C, Chris thinks that the square root of 0 doesn't exist, but if you put square root of 0 into your calculator, you'll see that it does tell you it's 0, right? And why is that? Well, because if we're thinking of what number squared gives me 0, right? 0 squared gives me 0, so that does exist, right? So I'm just going to say the square root of 0 does exist. It is 0. Okay. All right, so just those are kind of to help with a little bit of misconceptions that oftentimes students have with these square roots, and just trying to clear up some of those things, maybe some questions that you had in your mind when you were doing like the homework or something like that. Okay. All right, so I'm going to kind of rewrite this just a little bit because I want you to think about something here on these. Okay, so I want you to think and answer this question, or these 4 questions for me. Okay, does the square root of 9 plus 16 equal the square root of 9 plus the square root of 16? All right, so this is one of my questions. Then I also want you to think, so I'm going to write these 4 here, and I want you to just try and answer these. Square root of 25 minus 16 equals the square root of 25 minus the square root of 16. And then down here, does the square root of 4 times 25 equal the square root of 4 times the square root of 25? And the last question, does the square root of 100 divided by 25, right? So all of that's inside there, 100 divided by 25. Does that equal the square root of 100 divided by the square root of 25? All right, so these are kind of the 4 questions I want you to think about for just a minute here. Put those on there. Take a few minutes and decide. I want you to come up with an answer, yes or no, on these. Okay, I want you to write your answer in the chat box, right, for number 1, just for number 1. What do you think? Does the square root of 9 plus the square root of 16 equal the square root of 9 plus the square root of 16? So everybody just write it into the chat message. Don't hit enter quite yet. So just write a yes or no. Does that square root of 9 plus 16 equal the square root of 9 plus the square root of 16? All right. 3, 2, 1, hit enter. Ooh, Braxton, you seem pretty, pretty animated about that one. Why do you think that's no? How did you determine that?
Because when you add 9 and 16, you are going to get a different square root than when you separately.
So let's just do it. What is 9 plus 16?
It was 5.
What, 25? Yeah, square root of 25, and then this.
Yeah, sorry, I meant that.
That's okay. Yeah, and so then the answer would be 5. And then what about on this side? What's the square root of 9?
3.
And then the square root of 16?
4.
And so 3 plus 4 is 7,
7.
right? Not 5. So cool. Awesome. So that does not equal each other. So this tells us that if something's connected by addition, we can't just separate those out into 2 separate square roots, but I see students that try and do that a lot. Okay, so we know this doesn't work for addition. Okay, what about for the subtraction one? All right, so let's try this now. So put in, like, put 2 period or something like that, so I know you're talking about number 2 now, right? So you'll write like 2 period and then write either yes or no in your chat box. Okay, so everybody write that into the chat box. Does everybody know where the chat box is? Has everybody found it? Remember, if you kind of hover over the top of your screen with your cursor, you'll see a drop down that comes up. And then you can just click on that chat, and then a chat box will open up on part of your screen. All right, so for number 2, all right, everybody have your answers in? Let's try this again. Okay, 3, 2, 1, hit enter. Awesome. What a good Answers here. Most of you are saying no on this. Okay. Luciana, can you explain to me why you said no on that one?
So I saw, trying to like do it, and I subtracted 16 from 25,
Mm-hmm.
so it gave me 9.
Okay.
And then I just square root of 9, and it gave me 3, and then I did individually square root of 25 minus square root of 16, which was 5 and 4, and it gave me 1.
Okay.
So it wasn't the same.
Right. Is that what everybody did to do that? Right, so you can see, right, if you're using some numbers, and that's why I wanted to use some numbers rather than the variables that they gave in the book, because I think it's harder to think about just with variables. But if you can see like numbers that is happening with, you're like, okay, yeah, this does not equal each other, right? Okay, let's look at number 3 now, right? So we said it doesn't work for addition, it doesn't work for subtraction. Let's see, does this work for multiplication? Can we split those up into 2 separate radicals when it's connected by multiplication inside? Okay, so again, put number 3, like 3 period, and then write either yes or no into the chat box. Everybody got it in? 3, 2, 1, hit enter. Okay, so a lot of you this time are saying yes on that. Rachel, can you explain to me why you think this one does work?
Yeah, so I did the first one first, the 4 times 25, and I got 100.
Okay.
The square root of 100 is 10.
Okay.
And then the square root of 4 is 2, and the square root of 25 is 5, and 2 times 5 is 10. So that does work.
Awesome. Yeah, so that one does work, right? So remember, when you're seeing it like this, it's saying multiply. When you have that, you know, this first side, it's saying multiply the 4 and the 25 together, then take the square root. Or over on the right side of the equation, it's saying take the square root of them first and then multiply them together. Okay, so this one does work. Awesome. Okay, let's do the last one. So number 4. On this, get your answer in your chat box. You think this one works or not? Do these two things equal each other? Okay, everybody's got it in? Let's try this. 3, 2, 1, hit enter for number 4. Okay, well, most of you are saying yes on that one also. And kind of similar to what Rachel was saying up here on this one, right? On this one, if we divide our 100 divided by 25 first, we get 4. Square root of 4 is 2. Where here, if we do these separate, right, we get square root of 100 is 10. And then the square root of 25 is 5. And then 10 divided by 5 is 2. So that does check out. Right, so basically what this is showing us, and this is for any of the numbers, so if things are connected by multiplication or division, we can separate those out, and that's going to make it easier for us on some things that we are trying to simplify, to separate these, you know, into 2 separate radicals. But when they're connected by addition and subtraction, you can't do that. Right? And that's where a lot of people, you know, they think they can do it for all of the operations, add, subtract, multiply, and divide, but just multiply and divide work on that. Okay? All right, I want to put a few things in the punchline. My punchline kind of is a small box here, but let me try and write some things in here that we've, so my punchline box is going to kind of be over here. All right, so remember that the symbol, this symbol right here, right, is the square root symbol. right? But this symbol means the principal square root, which means it's going to end up being positive always, or we'll say non-negative. So you'll get a non-negative answer. Okay. Then another thing to make sure that we know from this section is that the square root of 0 is just 0. Right? You can find the square root of 0. And that if we try and find the square root of some negative number, right, so I'll put this all inside here. If we try and find the square root of some negative number, it's going to give a non-real solution. Okay, so it's going to give this non-real, and we're going to talk about what we mean by non-real. We're going to be talking about imaginary numbers today, and they're also called complex numbers, but that's what you need to remember when you have a square root, a negative inside the square root, that is what you're going to have happen there. Okay. All right, any questions you can think of so far on what we talked about? All right, so this next stuff that we're going to talk about with the complex numbers, these imaginary numbers, are actually not inside your book. So you need to just get out a notebook, some lined paper or something that you can take notes on to talk about these complex numbers. All right, so it seems like whenever I teach about imaginary numbers, students are always like, why do we have to do imaginary numbers? You know, they're not real, you know, I mean, they're, you know, so I guess sometimes people think, oh, they're like imaginary friends, but, you know, but no, right? Imaginary numbers are just, they're a different number system. So in math, there's a ton of different number systems. And if you go on in math, you'll talk more about these number systems. But in the classes, you know, that you've had so far, they'll focus on the real numbers. And maybe you've had some classes that talk about imaginary numbers also. But those are kind of the two systems that you might hear about so far. But there's a lot of different number systems. But imaginary numbers are important and they're needed. Like if you're doing any kind of electrical engineering, so you're trying to make, you know, any kind of little handheld device, you would not have those handheld devices without imaginary numbers. So it is really important to understand about imaginary numbers. And it's, you know, not that you know, some of you are thinking, well, I'll never use this. I'm not going to be, you know, making those things or doing that. But just understanding like that they have importance and where those are coming from is what I wanted to talk about. And it's kind of funny when we're talking about imaginary numbers, people are like, why did they give it that name? You know, and complex numbers isn't much better. Makes it sound like it's really hard, and it's not really hard. Imaginary numbers, I think a lot of people get in their mind that, oh, they're so difficult. But there's just a couple of different things that you need to know about imaginary numbers. Okay, so when you're trying to find the square root of -1, right? So when there's a negative inside the square root, rather than having that square root of -1, we're going to call that I. So everywhere you see a square root of 1, instead we're going to use the letter I to illustrate that, right? And so if we take, let me show you this again, I'm going to write this out again. So if I take the square root of negative 1 equals I. Right? And if I'm trying to undo square rooting something, then I'd want to square both sides of the equation. Because remember, I said when I square root or square square root and square something, these guys are opposite of each other. And so I'm just left with what's inside on this side. So I've got negative 1 equals I squared. So these are the two things that you need to know for imaginary numbers. Right? I is always going to be, you're going to replace it when you have a square root of negative 1. If you have an I squared, you're going to replace it with a negative 1. So knowing those two things, and then really from there, everything just acts like these i's that we have, just act like any other variable that you've dealt with before, x's and y's and whatever. And so that's what I'm going to show you next in some of these examples is, well, let's first talk about, let's try this. So I'm just going to put some examples here. So for example 1, if I ask you to rewrite or write as an imaginary number. Okay, so let's do this first. So I'm going to be a few parts here. So part A, if I want you to rewrite the square root of negative 25, right, because we can't have a negative number inside a square root and have a real answer. We're going to have an imaginary number. So I could break this down to be, since I have that negative 1, right, it's really saying like negative 1 times 25. Right? Or I can think of it as negative 1 times 5 times 5. Right? And then I have two of the same, so the 5 gets to come out. And then that square root of negative 1 instead is I. And so my answer is just 5I. Okay? So whenever you see that negative inside there, you're just going to be writing it as an I instead. Let's try another one, and then think of any questions that you have as I'm kind of going along here. All right, what if I have the square root of negative 3? Well, this one, 3 is not a perfect square, but when it has a negative inside, we still need to rewrite it so that there's an I there. So I'm going to show it like this. So remember, this could break down to be negative 1 times 3. And so that I, that square root of negative 1, gets to come out as an I, but the 3 is still stuck inside that square root. So we write it as I times the square root of 3. Or sometimes, and I don't like it really written this way, but sometimes you'll see people write it as square root of 3 I like this, but sometimes it's hard to tell, are they saying that I is underneath the square root or not? So I like it better this first way, but just so it's more clear on what you're talking about there. Okay. All right, let's do one more of this type. What if I have, so the opposite or negative square root of negative 50. Okay. So we can't just distribute that negative through to this. We've got to simplify what's inside the square root first of all, right? So if I took my 50 and I did the prime factorization of it, that's going to be 5 times 10, and then 10 breaks down to 5 times 2, right? And so if I rewrite this out, I've got negative on the outside, and if you want to write it as a negative 1, just to kind of help you remember that that's what's happening here. So you've got negative 1 times, these are connected by multiply, the square root of negative 1 times 2 times 5 times 5. I'm just breaking these down kind of like we talked about last time. And then I can see, all right, so my 5 gets to come out, right? And that square root of negative 1 also is going to come out as an I. So when I bring these out, I've got my negative 1 times, that 5 is coming out, square root of negative 1 is coming out as an I, and then 2 is still stuck inside. But when I simplify this all the way, I get negative 5I square root of 2. All right, what questions can I answer on those? Please speak up. Go ahead, if you have a question, just unmute yourself and ask your question.
For the negative 5I, could you write it 5I cubed? Because negative 1 is I squared.
No, because the I, remember, if we're doing this, negative 1, so the square root of negative 1 is I, but we have to bring it out as that I there, right? We're not dealing with this I squared. We don't have I squared anywhere there.
Well, I'm saying, could you change that negative 1, like negative 5, change it to negative 1 times 5, and then change that to a negative I, or positive I squared, and multiply that by I to have I cubed, or is that just too much work?
Yeah, that's not going to be how we're going to want it written. You know, I mean, yeah, we are saying that, you know, negative 1 is I squared, but this is usually to help us simplify. So if we have anything as I, we could change it to something that's not an I. So we usually are going the other direction. So yeah, so we don't want to put that in as an I squared there, because yeah, that wasn't even inside a radical or anything like that to start off with, right? That negative 1. So yeah, just leave it. Just multiply those all together there. You're just kind of treating these like any kind of a variable like we've had before. Okay, good question. Other questions? Please speak up if you guys have questions. I can't see your faces. I have no idea, right, what you're thinking on this unless you speak up. Okay, so let's go to the second example. Okay, on this one, a couple here. So multiply or divide, and then rewrite or write in terms of I. So if we have something like this, the square root of negative 3 times the square root of negative 7. Okay, so we actually, when we see that we have a negative inside the square root, right, we can't just multiply these together like we could if they were positive numbers, because these are not real numbers. These are imaginary numbers, so I need to treat them as such. And so what I'm saying here is that you've got to rewrite each of these first as imaginary numbers first. Okay, so let me see, I'm going to put that here. So rewrite each as imaginary number first. Okay, so let's do that. So if I take this part, right, and remember that when I have that negative, that means an I is going to come out, and then the square root of 3 is still stuck inside. Right, and then on this one, I gets to come out because that's my negative part there, and then square root of 7. Right, that 7 has to stay inside. And then with radicals, we can always multiply what's on the outside together and what's on the inside together. Okay, so when we do that, maybe I'll keep it like this. So the I times I is my I squared. And then square root of 3 times 7 is 21. All right, so I get I squared times square root of 21. Anybody see anything else that we can do to simplify this more? There's one more thing we could do.
Could you get rid of the square root by squaring it?
So if we were trying to solve an equation, that's what we would be doing, is we'd, square both sides. But what about this I squared? What did we say I squared equals? Remember up at the top?
-1.
Yeah, so we're just going to change that. So when you see like the square root of -1, you're going to change it to an I. Right? When you see an I squared, you're going to change it to a -1. That's just going to help us to simplify this a little bit more. Right? So we'd have negative, or you can write it as a -1 if you want to, square root of 21. And that would be our answer on that. Okay, we'll call this one part A. Let's do one more over here. So what if I have the square root of -8 over 2? So notice my 2 is not inside a square root. All right, so I'm going to first work on getting this. I see I have a negative inside a square root, so I need to change that so it's in terms of I. Right? And so let me break that down. Right? So if I do 8 in factor tree, that's 4 times 2. And then 2 times 2 times 2, right? So really, oops, I need to put all of that there. Okay, so we really have the square root of -1 times 2 times 2 times 2. And that's still over just 2, right? You can't do anything on the bottom yet. Right? And then I can see, all right, what can I simplify? Well, I can see a 2 gets to come out, and I can see a square root of -1, right? So that's going to come out as an I. So on the top, I have a 2 and an I that get to come out, but then there's still a 2 stuck inside that square root. Right? And now I have a 2 on the bottom. And then we can simplify this a little bit more, because now notice, here starting off, we couldn't do -8 divided by 2 because this isn't really -8. That's the square root of -8, right? But after we simplify it and we see, okay, now I've got this real number here on the outside. These two, 2's mean the same thing. So meaning I can cancel these guys out, right? But I couldn't cancel the square root of 2 with the 2, because square root of 2 is really like 1.41 blah, 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 right? So doesn't make any sense to try and divide those out, because they need a divide out to be a 1. And so then that just leaves me with I square root of 2. And that would be your answer on that one. Okay, so when you see numbers that you're trying to multiply together and stuff, and there's negatives inside the square root, make sure you change those to imaginary numbers first before you start to, multiply or divide those. Okay, what questions can I answer there? What was that? Sure.
So on this example, switch the I squared to the -1. So on this one, would you keep it as I, or do you change that to -1 as well?
Well, so remember that the square root of -1 is I, right? And I squared is -1. So we're trying to make it so, you know, like on here, if we don't have to have, you know, these i's in here, we want to simplify those more so they're not, you know, so that's why we change that to a -1. But here we don't want to take that back to a square root of -1 because that's going to give us a negative back inside our square root. So the whole thing that we're trying to do here is simplify it so that there's no negatives inside the square root.
Okay, thank you.
Okay, good question. That's really good. I mean, and these are new for a lot of people, so please speak up. You're like, I need help understanding this. All right, well, let's take a little break right now. Been going for about an hour, so let's take a little break, and then when we come back, we'll talk some more about these complex numbers. Okay, and feel free to unmute yourself and talk to each other too on here. So a complex number basically has two different parts to it. It has the real number part, right, and that's this A when it's written in this form. And then the part that has the I in it, right? So this part here is our imaginary number part. And so a complex number means that it has, you know, both real numbers and imaginary numbers together. And you'll always see that they want the answer written in this form, where you have the real part first, and then the imaginary part second, right? So that's what I mean by this A plus BI. Okay, so put the real number first and the imaginary number part second. Okay, so let's look at some things like that with some of these complex numbers where we're going to we'll add, subtract, multiply, and divide with these now on this next part. So I guess we're on example 3. I'm at. Okay, so on this one, I want you to add or subtract, and then make sure you write the answer in the A plus BI form. So part A, let's look at this. What if I have in one parenthesis 5 plus 2i? And then we're going to add that to 4 minus 3i. Okay, and really, like I said before, we're going to treat this I like it's just any other variable. So don't, you know, let that, you know, trip you up in what we're doing here. So to start off, right, we'll be adding the 5 and the 4 together, and then because we're going to combine like terms, and then we're going to add the 2i with the negative 3i. Right, so if I add the 5 and the 4 together, I get 9. So that's my real number part there. Right, and then I have the 2i minus 3i, which is going to give me just a negative 1i, or negative I. Right, so I'm just combining those two different parts together, and then that would be my answer on it. Okay, so don't overthink some of these. You know, just treat them like it was an X or something instead. All right, what if I have something like this? Let's do 8 minus 4i, and then minus, so notice I've got the subtract sign here now, and then in parentheses 2 minus 3i. So with that negative out in front, this is kind of like a -1 that you've got to distribute through to both of those. Okay, so we've got to do that first. So let's rewrite this down. So I've got, this part's not going to change, 8 minus 4i. And then if I distribute that -1 through, I get -2. And then negative 1 times negative 3i is a positive 3i. Okay, and now I can combine my like terms together, but you got to remember to distribute that through like you've done on other ones, right? So my real number part, right? So 8 minus 2 gives me 6. And then my imaginary number parts, negative 4i plus 3i gives me a negative I. Or you can put negative 1i if you want to. But that would be our answer there. Okay, questions on adding and subtracting complex numbers? Okay, let's look at multiplying some complex numbers next. Oops. So multiply, and then again, make sure that you put it in the form, right? Form of a plus bi. All right, so what if we have this? So part A, we've just got negative 5i times 3i. So again, we're just going to multiply our whole number parts together. So the negative 5 times the 3 is negative 15. And then I times I gives me I squared. Right? And then whenever I see an I squared, I'm going to replace that with a negative 1. So I'm really going to be doing here, like, instead of I squared, I'm going to replace that with a negative 1. So I'm doing negative 15 times negative 1. Right? And then that will give me a positive 15 there. Okay, let's look at another one. What if I have this? I want everybody to try this one. I'm going to give you a little bit of time to do it. So what if I have negative 2i on the outside of the parenthesis, and then 6 minus 2i on the inside? All right, so really you're just using the distributive property here and then simplifying it. Okay, so everybody try that and see what you come up with there. Okay, and raise your hand when you have an answer on this. All right, Joe, would you mind walking us through how you did this problem?
Alright, so I did the distributive property, and I got negative 12i plus 4i squared.
Okay.
And then told us that minus 12i.
Yeah. All right, and I'm glad that you put it in that form, right? So we need to have the real number part first and imaginary number part second. So we had to kind of move that around a little bit. So that should say 12, not 2. All right, so negative 4 minus 12i would be how you write that answer. Awesome job. Thank you. All right, so remember, if you see an I squared, you just need to change that to a negative 1. Okay. What if we have some binomials multiplied by each other? All right, so if I have 3 minus 4i, and then in parentheses right next to it is 6 plus I. Right? And I want to just quickly go up and make sure that you see the difference, because on the homework, people tend to make a mistake here, right? On this part A and part B, they have an add sign in between on part A and a subtract sign in between on part B. But notice that there's nothing, right, between our two parentheses here. We're just multiplying these together. So this is where we're doing the FOIL method. Right? So we're going to take, you know, our 3 times 6, and that will give us 18. And then we'll do our 3 times 1, which will give me 3i. And then I'll do my negative 4i times 6, so that's negative 24i. And then negative 4i times I is negative 4i squared. All right, so it's the same kind of thing that we were doing before when we FOIL these together, right? But now I can see I've got some like terms, those i's in the middle, that I can combine together, and I need to change that I squared to a negative 1. All right, so there's more simplifying that I can do here. This up a little bit. So when I write this out then, right, I've got 18. When I combine these guys together, I get negative 21i. And then I've got a negative 4 times a negative 1. Right, that, put it in a different color, just make sure it stands out to you. But that's what, you know, we're changing that I squared to a negative 1. And so that's going to give me a positive 4 that I need to add to my 18. Right? So I'll just write it out this way. So I've got 18 minus 21i plus 4. And then I'm going to combine my like terms together. So I get 22 minus 21i. Right? So whenever I see that I squared, I need to change it to a negative 1. But other than that, it's pretty much the same as when we FOILed before. Right? It's just kind of one more thing that you got to remember there, that whenever you see the I squared, you're going to change it to a negative 1. Okay. Questions on that one? Okay, let's try another one. So part D on this, let's try, what if we have 1 minus 2i all squared? So what does it mean when this whole thing is being squared? What do I need to do here? Anybody remember? Can I just distribute that 2 through to both of them?
Multiply like 1 minus 2i again.
Yeah, so you've got to write it out, right? 1 minus 2i times 1 minus 2i. All right, so I can FOIL those together, right? So this is still a FOIL question, but sometimes when people look at this, they're not thinking of it as such, just because the way it starts off. Okay, but we're still going to FOIL that together. Right? So when I do that, right, my first terms multiplied together, I get 1. Right? My outside term, I get negative 2i. My inside term, I get another negative 2i. And then my last term, I get a positive, right? Negative 2 times negative 2 is a positive 4. And then I times I is I squared. Okay. And so then again, I'm just going to combine those like terms together and make sure I change that I squared to a -1. So 1 minus 4i, right, just adding those -2 and -2 together, and then plus 4 times -1, right, my I squared is -1, so 1 minus 4i minus 4. Get those like terms together, so I have -3 minus 4i. Putting the whole or the real number first and the imaginary number second. Okay. All right, everybody try this next one, and when you get the answer, put the answer into the chat box, but don't press enter yet until I tell you to, okay? So I want everybody to try this one out, and so I can see how you're doing with it. So 6 plus 5i in one of the parentheses, and then 6 minus 5i in the second parenthesis. Okay, so multiply those and simplify them so they're in the a plus bi form. Okay, so let me give you a couple minutes to do that. Raise your hand if you have an answer on part E. Give you a little bit more time. When you find an answer, go ahead and hit that hand raise button so I know you're done. Okay, remember when you have your answer, go ahead and put that answer into the chat box, but don't hit enter yet. All right, so everybody have it into your chat box we have for an answer. All right, 3, 2, 1, press enter. All right, a lot of people are coming up with 61 for the answer, it looks like there. That seems kind of weird, doesn't it? We're taking two, right, imaginary numbers, these complex numbers, and we're multiplying them together, but we only come out with a real number answer. And you're correct, 61 is the correct answer in that, and I'll work through it here to show you. But what I want to explain is that these are complex conjugates, is what we call them. So write this down next to it here. These So complex conjugates. That's a really weird sounding word, but basically it just means it's the same thing multiplied by each other, except one of the factors is connected by a plus sign and the other one's connected by a minus sign. And whenever you have complex conjugates, you'll always end up, so when you're multiplying, let's see, I'll put when you multiply complex conjugates, you always get a real number. Okay, so that's kind of the cool thing about these complex conjugates. All right, let me work through it really quick to just show for those of you that didn't get that. Right, so 6 times 6 is 36. And then 6 times negative 5i is a negative 30i. And then 5i times 6 is a positive 30i. And then I have my last terms, 5i times a negative 5i is negative 25i squared. Right, so I can see what happens with these conjugates is those middle terms cancel out. Right, those are just gone. They go to 0. And then I'm just left with that first and last term, but that last term has an I squared in it, so I need to change that to be a negative 1. So I have 36 minus 25 times negative 1, right? Changing that I squared to a negative 1. So I really have 36 plus 25, which gives me 61. So that's how I end up with that real number, right? There's not an imaginary part anymore on that. Okay? And so that kind of leads us to the division. So our next example is going to be about dividing when we have these complex numbers, right? So example 5, is that where we're at? I think. All right, so again, it'll say divide, and then put answer in a plus bi form. Right, got to remember that always whenever we're dealing with these complex numbers. This is the form it's going to always want it in. All right, so when we have our first one, and these look kind of weird, and some people are like, it doesn't seem like we're dividing. And so I know that sometimes these directions seem kind of strange, but this is what the question looks like. It says 2 plus I on the top, and then 1 minus I on the bottom. All right, so when we're dividing, when we have these imaginary numbers, what we're really doing is we're trying to figure out what the complex conjugate would be of the denominator. So let me write that up here. So find the complex conjugate, these are weird words, of the denominator, right, the bottom part of the fraction. And so remember we said that the complex conjugate, right, they're conjugates if they're exactly the same, except this one's connected by a subtract sign, so that means this one has to be a plus sign. And then I'll just be foiling these together, right? And I want to do that so that I end up with a number that doesn't have any kind of an imaginary part to it, right? But whatever I, do, on the bottom here, I've got to also do that same thing on the top. So I'm multiplying the top by 1 plus I also, right? Because 1 plus I divided by 1 plus I is just really 1. And if I can multiply anything by 1, right? It changes how it looks, but it doesn't change the properties of that problem. So I'm going to be foiling on the top and then foiling on the bottom. Okay, so go ahead and work yours out, FOIL on the top, FOIL on the bottom. I'll be working out alongside here too, but I'm going to be quiet so you can try and think about what you're doing there. Okay, but look up here if you have some questions. I messed something up here. Hold up. That should not be. Okay, let's see how far you got on this, right? So we FOIL on the top, FOIL on the bottom. And on the top, right, I need to combine my like terms together there in the middle. So I get 2 plus 3i, and then I change that I squared to a -1. And then I'm combining my real number parts together. So 2 minus 1 gives me a +1, and I still keep that 3i. Right, on the bottom, do the same thing, FOIL it. But this time my middle terms cancel each other out, right? And that's because they are complex conjugates. We're making that happen. And then that I squared needs to be changed to a -1. So I have minus -1, which is really adding 1. So I should have 2 on the bottom. And then I need to separate these out because remember, I still need it in this form of a plus bi. And so I'm going to divide both parts by the 2 so that I can still have it in that. So here's my a is 1/2 and 3/2 is my b, right? And then the I. So if you left it here, just keep going one more step and separate it out so that we have it in that a plus bi form. Okay. What questions do you have on that one? Go ahead and speak if you have a question. Just unmute yourself and speak.
The complex junction, is it just the opposite of the denominator?
Yeah, so it's one if it starts with a subtract sign in between it, you put a plus sign in between it. If it started with the plus sign in between, then you'd put the subtract sign. But yeah, everything's the same except one's connected by plus, one's connected by minus. Okay, good. Good question. Make sure we understand what makes that complex conjugate, what we want to multiply by there. All right, let's do one more. This one isn't going to be quite as involved there. It's going to look a little bit different. But if we have 7 minus 4i divided by 3i, and it again gives you the same instructions, it doesn't really look like we're dividing here, because what we're going to end up doing is you could either multiply it by what's on the bottom, but you're just thinking about how can I, get rid of this I on the bottom? Well, if I times the bottom by I, that would make this an I squared, which is really a -1. So on something like this, where the bottom isn't a binomial, it's just a monomial, then you can just multiply the top and bottom by I. Right? And so when I do that, it's like I'm distributing. So notice that you're taking all of this on the top and you're distributing that I to it. Okay, so that's going to give you 7i and then minus 4i squared. Right? I'm just distributing that I through. And it looks kind of weird because it looks a little backwards in how we usually distribute there. And then 3i times I would just give us 3i squared. Okay. Who thinks that they could tell us what you might do next here? What would you think of doing next? Can I combine my I and my I squared together? I can't cancel these guys out because one's connected by subtraction, right? And those would have to be connected by multiplication. So what if I change my I squares to -1s? Right? I can see that. So I'm going to say 7i minus 4 instead of a I squared. I'm going to change that to a -1. And on the bottom, I'll have 3 times -1. Right? So whenever I see I squared, I'm trying to get rid of those i's as much as I can, and I'll change those to -1. So then that gives me on the top 7i plus 4, and then on the bottom, just -3. So again, kind of like we did up here, we can't leave it in this form. We need to divide both parts by the -3 on that. So that's going to give me negative. Well, and I want to make sure I have it in my a plus bi form. So I'm actually going to put this first, right? So -4/3. Right. Let's see if I can, let me do it with different colors to make sure everybody's seeing what I mean here. So let me do this in this color. So if I'm saying, okay, this is my real number part, so then that's going to be -4/3 is what's written first. And then my second one is going to be this divided by this. Right? So that's going to be minus 7/3 I. And then that all together is my answer.
So is that with everything we do with the when it's squared? We put in the -1?
Always. Always, always, always. That's one of the biggest differences, right? Between, you notice most of it looks the same as foiling, except you're going to get this I squared. And every time you get an I squared, you got to change that to a -1. So always. Okay, good question. Other questions? All right, there's one more thing that I want to talk about with imaginary numbers, and I want to talk about how the powers, there's kind of a pattern with imaginary numbers. So let me kind of write this down. I'm going to look at a few things here. So notice if I have I to the first power, that's just I. If I have I to the second power, well, remember we said one of those, one of the properties that we know about imaginary numbers is if we have an imaginary number squared, that's going to give us -1, right? And then what about if I keep going up, right, and try and figure out, well, what is I to the third? What is I to the fourth? Right? And then I to the fifth, and I to the sixth, and I to the seventh, and I to the eighth, and so on, right? How could I figure out what these are? Well, I to the third, right, you could really break that down to be I squared times I. Just breaking it apart in that way and trying to make as many I squareds as I can, because I know I squared simplifies to be -1. So that will make this simplify easier. So that's really saying -1 times I, which is going to give me a -I. All right, so let me see. I'm going to take these. So that's the answer to this one. That's the answer to this one. So I to the third power is really -I. All right, now let's look at I to the fourth. Well, I to the fourth could be written as I squared times I squared. Remembering that we want to break, our exponents down to as many I squareds as possible, because then that really just gives us -1 times -1, which gives us a +1. So I to the fourth power always simplifies to be a +1. Okay? Now look what happens when we come over here to I to the fifth. Right? So I to the fifth is the same as, I'm going to kind of write these out maybe a little bit of a different way. So if I could say I squared squared, right? That's a I to the fourth times another I. Well, I know I to the fourth was 1, so this is just saying 1 times I, which is just I. Okay. Oops. What happened there? So we have I again, right? So now let's go to I to the sixth. Well, I to the sixth could be written as I squared cubed, right? Because remember, when we have a power raised to a power, we multiply those together. And so then this is really saying -1 all cubed, which is just going to be -1. All right, let's do I to the seventh. Well, I to the seventh is I squared cubed, I to the sixth, times another I. Right, so remember that I to the sixth we said was -1, so this is going to be -1 times I, which just gives me a -I. And then on the bottom, I to the eighth is I squared all raised to the fourth power, right? Because a power raised to a power gives us, 2 times 4 gives us the 8. So let's say -1 all raised to the fourth power. Well, -1 times -1 times -1 times -1 is going to give you a +1. Right? So hopefully you can see there's like a pattern that's happening here. Right? And this is called, it's cyclical, meaning it's going, this is simplifying to I, then -1, then -I, then 1. And then the same thing happens, right? Over again. I, -1, -I, and 1. And so all of our I powers are going to simplify to one of these 4 things. And so, I mean, sometimes students are okay with writing it out like this, but there's another way that you could kind of think through it, especially when our, power gets really big. We're, like not wanting to, go through this whole thing. So let me show you what we're going to do to simplify some of these. So here's example 6. I want you to simplify. Let's do I to the 31st power. Okay. So like I said, we could kind of keep doing the same thing we were doing here, but there's kind of a shortcut way that a lot of people like to take. Notice we said, okay, there's 4 possible answers here. So we could take this 31 and divide it by 4, right? And it doesn't matter how many times it divides in, but the remainder that's left is going to tell us which one of these 4 it is, right? So 31 divided by 4, right? So we'll go in 7 times, right? With how many left over? 3 left over, right? So if I just tried to do a little division here, 4 goes into 31, 7 times, right? And then 3 left over. And so this remainder part is the part I want to focus on, okay? Because you'll get I whenever your remainder is 1. Your answer will simplify to be -1 if your remainder is 2. Right? When your remainder is 3, you get -I, and when it divides in evenly, right, meaning it's leaving no remainder, then you'll end up with a 1. Okay, so on this one, all right, let me rewrite this. So I to the 31st power, since when we divide it by 4, and it's always going to have to be divided by 4 because that's how many possibilities we have. That's why we're dividing it by 4. When we took our exponent, divided it by 4, we came up with a remainder of 3, so that means this is going to simplify to a -I. And so -I would be our answer there. All right, well, how could we check it? Well, let's check it the same way that we did here. So I to the 31st power would be I squared. Remember, you're always trying to write things as many squared as you can. To the 15th power, because 2 times 15 is 30, but then we still need another I to make 31. So here we have -1 to the 15th power times I. Well, when we have a negative number raised to an odd power, that just simplifies to be a negative, and -1 times I gives us that -I that we just said here. All right, so you can think of it this way, or you can think of it this other way that I have here. Both ways are great. Both work wonderful. If you're trying to do it this way, you've just got to remember the order that they're in, right? I, -1, -I, 1. So you remember which one's remainder 1, remainder 2, remainder 3, and divides in evenly. Okay, let's just try a couple more of these and these same type, and then we will be good for the day. It's been long. I'm sorry. So let's try. What if we do I to the 50th power? Okay, so try and figure out what that one simplifies to be. And I'll try one more. Let's do those two. Okay, so in example 7, if you do it the division way, right, we're trying to figure out how many times will 4 divide into 50, but really what we want to know is the remainder. And so in this one, the remainder is 2, which means it's going to simplify to be a -1 for our answer. Right? If you did it the other way, right, where you're saying, okay, I squared to the what power gives me 50. Well, there's not, I mean, if I did it to the, let's see, what was I thinking of there? To the 20, oh, wait a minute, what am I doing here? Yeah. I to the 25th power, right? So 2 times 25 gives me 50. So that will work. And then I'm just doing -1 to the 25th power. It's an odd power, right? And so that means my answer will be -1, right? So either way you can do these and it works. Okay. All right, let me give you just one more minute to finish this one up. And then when you get that answer, I want you to type it into your chat. Again, don't hit enter yet. Just type it in. Okay, so everybody get that in your chat? Okay, 3, 2, 1, press enter. Okay, looks like most of you are coming up with -1 on there, so that's really good. Lily, how did you come up with your answer? Which way did you do it? That's what I'm wondering.
I just did it with the division method.
Okay. How many of you by raise of hands did the division method? Just curious. Some of you have your hands raised, so. Looks like a good number of you are doing it that way. Both ways work just great, but either way you do it, you should get -I, right? If we do it the division way, we're saying how many times will 4 divide into 39? All right, well, go in 9 times. 9 times 4 is 36, leaving a remainder of 3, right? And remainder 3 goes along with that -I. If you did it the other way, you're trying to figure out as many I squareds as you can, right? So I squared to the 19th power, right, is going to give us I to the 38th, and then you have to times it by another one. So -1 to the 19th times I, so -1 times I still gives us -I. But you pick which way works better for your brain. Either way, you're going to get the same answer on those. Just make sure you know you have a way to simplify it, and they'll always simplify to be one of those 4 things, right? Okay, well that is where we're going to finish up today. So for your homework, I do have, there's a quiz that I posted on there that I want you to work on over the weekend and get it done by the 14th. There's also that, so some of you worked on the 9.1 already, but know that there's a 9.1 part B also that's dealing with these complex numbers. And then, and that's really as far as we got today. So just make sure that you get up through that point, that 9.1b, and also work on that quiz. And remember, with the Lab 10, just one person from your group needs to get that put in. I know it's just kind of messed up this time, but if you have questions about it, about that Lab number 10, please ask me about it so that I can give you some feedback and any help on that you need help on, okay? Any other questions that you have?
Yeah, I have a question.
Yeah.
So I wasn't there for last class, and do I just need to get with my group to finish Lab 10, or?
Yeah, or you could just finish it up on your own. Somebody will have submitted it, and you'll get the points from that, but I would still encourage you to make sure you know how to do that Lab 10 on your own. You just won't have to submit it, because somebody else will have submitted it. But yeah, you can talk to your group members, on chat and stuff like that in the assignment there if you don't have their numbers or another way to reach them. But yeah, you can always reach out to them on Canvas. Okay?
And then one more question.
Yeah.
9.1b on affinity.
Yeah.
Okay.
Yep, so there's 9.1a and 9.1b, and they're both on Edfinity. Okay, if you have some individual questions that you have, stick around and I'll answer those for you. Otherwise, I will see you guys next week. Have an awesome weekend, but keep reaching out to me. Email me when questions come up for you, okay? Have a great day.
Thanks.
Yep.
Thank you.
See you guys. I miss seeing your faces.
Same here. Bye.
Bye. Casey, did you have a question?